got to make sure I record this. So this one, by the way, I don't use old AP exam questions on my tests. I will use like the idea, but then I change things so that I can quickly know who leaves my classroom, looks up the AP test question, Googles it, comes back, gives me the perfect AP exam answer, but it doesn't match anything in my question. So I'll use this similar situation. It's a great way to catch cheaters. But this one actually is an old AP exam question. So we're going to work through this one. Anybody want to read for me since I get to do most of the talking today?
For sure.
Oh, thanks, Nate.
So you just wanted to read number one? Or-
Yeah.
Okay.
I guess, sorry, I will preface it. Those are the directions that are stated on the AP exam for an FRQ. Those are the directions I put on my test for an FRQ. So you'll get used to seeing them. Show all your work, indicate the methods you use, because you're scored on the correctness of your methods as well as the accuracy and completeness of results and explanations, which is pretty much a math question. We give you partial credit for work shown, if it's correct. Go ahead.
Okay. As a part of the United States Department of Agriculture Superdome cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. 3 of the targeted sites, River X, River Y, and River Z, had become contaminated with pesticides because they were located near abandoned pesticide dump sites. Measurements of the concentration of aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. The box plots shown below display the 5-number summaries for the concentrations in parts per million of aldrin for the 20 locations that were sampled in each of the 3 rivers.
Thank you. So we have our 3 box plots. We have River X up at the top, River Y, and then River Z. So the first part of this question is to just compare the distributions of the concentrations of aldrin among the 3 rivers. So compare the distributions. When you have to describe a distribution, I ask you to go through SOCs, shape, outlier, center, spread. So when you're asked to compare distributions, you want to make sure you hit on the 4 things. You want to compare their shape, compare if they have outliers, compare their centers, and compare their spread. So I will, sorry, I can't think and write and speak all at once. It just doesn't work. I've told you that when it says describe the distribution, you can do like a bulleted list. SOCs, and then just put the shape, the outlier, the center, the spread. Why are you 2 staring at him?
He's staring at it.
Okay. When it says compare, it is better to use sentences. I personally am not good at English. You guys will get tired of hearing me say that. I'm not good at English. So what I put up here is my best attempt at good grammar and good comparison. I'm sure you guys can be much more concise and put it better than I can. But I'm giving you an example. And I just go in order. Nowhere does it say in the AP exam that you have to talk about shape first and then outliers and then center and then spread. As long as you hit all 4 is what matters. So before I actually write anything, I'm going to look at what's going on with these box plots. There's my pencil. So the first thing that I noticed about the box plots is that River X, the median is higher than the median in the other 2. In fact, the median of River X is higher than all the samples in River Z. Last time we talked about how to know whether a distribution was skewed when looking at the box plot. So river X, because this part of the box is much bigger than that part of the box, that tells us we have skewness to the right. So I'm just going to make note that this is skewed to the right. Now, because this isn't my actual answer, I'm not going to worry about safety words right now. Okay? Remember, with box plots, outliers will be shown as a separate dot. So I don't have an outlier on any of these. So I'm going to make a note to myself there that I don't have outliers. The center was what? About, I don't know, it's bigger than 5 but less than 5.5. So how about 5.2? 5.25. And then our spread is pretty big. That's almost 9 to almost 3. Let's see, if we go 8.7 to what would you say that is? 3.3? 3.2? Let's go with 3.2, just make it nice. That's 5.5. And then I'm going to go through and make some notes about river Y, so that when I start to compare them, it's all right there for me. You guys may not need to make the notes. I like to reference things. But I am going to erase those so I don't confuse myself with all these other lines. So center of river Y is about 5. What's the shape of river Y? What would you say the shape is? Nobody?
Roughly symmetrical.
I would say it's roughly symmetrical too. Thanks, Sal. Outliers we already talked about. There aren't any. Center there is about 5. And then our spread is 6.5 down to, I don't know, 3.1. So that'd be what, 2.9? And then Z, what's the shape of Z? We know there's no outliers for Z because we don't have any separate dots. Nobody wants to make a guess about the shape?
Skewed left.
I would say skewed left. Bigger on the left side of the box. So, skewed left. Thanks, Nate. Center, I don't know, 4.2, 4.3. And then spread, that's like 5.1 to 3. Oh, I almost forgot. 5.1 to 3. That would be what? 1.9? No, 2.1, right? 2.1. Sorry. It's a Monday morning. So what measure of spread did I just use? I did max minus min. What's that called? Range, thank you. I was beginning to think that I hadn't done a very good job teaching. Range. This is range. I'm going to use R. What's the measure of center we use? What? Median. Excuse me, median. That's one of the 5 number summaries. Okay. When you use the median for your measure of center, what are you supposed to use for a measure of spread? It's non-resistant. IQR. So we can mention the range because it is important to show that like river X has a range that's almost doubled that one and not quite double that one. But we should also talk about the IQR. And remember, IQR is your Q3 minus Q1. So I'm just going to go back really quick and identify the IQR for each of these. Bless you. So that looks like what? 7.5 minus 4.6. So that'd be what? 2.9 there. And then the IQR of Y would be about 6.1 minus 4.1, so 2. And the IQR down here be like 4.5 minus 3.6, 3.8, I don't know, we're estimating. So now that I've identified all the socks for each of those box plots, now I'm just going to go through and make sure that I have a sentence, at least one sentence for each of the 4 parts of socks. So I'm going to hit on shape, I'm going to hit on outliers, center, and spread. And like I said, I'm sure you guys can make it sound much more elegant than I can. And I go in order, you don't have to. I am going to abbreviate river X as RX, river Y as RY, and river Z as RZ. By the way, if you like to use abbreviations, as long as you make some note, I will accept them and they accept them on the AP exam, as long as we can know what your abbreviation means. So I'm going to start by just saying that river X is slightly skewed to the right. See, this is where I threw in my safety word. Is there a question? No? Is Sam making eyes at you again?
Yeah, they're staring at me.
Come on, Sam.
You do so.
Come on, Eric. River Y is roughly symmetric. And river Z is, I guess I'll use slightly again, is slightly skewed left. Then I'm going to say none of the rivers have outliers. I don't know why I capitalized rivers, probably because I was abbreviating it before, but I don't know why I did, sorry. And my pen back. Center and spread, I would say, are where you want to elaborate the most. So our center for river X, 5.25. Here it's 5 and there it's 4.3. But we do want to mention that, like river X, as I said, the center is actually, maybe if I can get my pencil to work. The center of river X is actually greater than the entire box plot for river Z. So when I mention my center for river X, I want to make a note about that. So river X has a median And notice that I specified my center. I didn't just say center, I said has a median of 5.25. And what is it? Parts per million, ppm. Labels are important. They will look for labels on the AP exam. River Y has a median of about 5. I should have said about here because we are estimating, sorry. I'm going to use my squiggly equal sign. About 5 ppm. And River Z has a median of about 4.3 ppm. And then I'm going to make my extra note. River X's median is larger than all 20 samples from River X, or excuse me, River Z. And the median of River X is larger than what percent of River Y samples? Remember we talked about the quartiles. They break, box plots break it into 4 equal parts. 25%, 25%, 25%, and 25%. So we can say that the median of River X is greater than 50% of the samples taken from River Y. And of course my big handwriting has ran out of room. I'll just go down over here. River X's median greater than 50% of River Y's samples. Am I off the board? No, so River X's median is greater than all 20 samples from River Z, because here's my median from River X, and it's about the whole box plot. The median from River X is bigger than 50% of River Y's data or samples. Questions? Did your back pop? Okay. And then when we're talking about spread, you can hit on both the range and the IQR. So the range of River X is the greatest, then River Y has the next greatest, and then River Z, same with their IQR. X has the biggest, then Y, then Z. So I'm going to add that to it. Sorry, I have really big handwriting. You would think I'd learn to give myself more space, but I didn't. So River X has the largest range and IQR of the 3 rivers. Then River Y, and lastly River X. Why do I keep saying X? Sorry, River Z, X, Y, Z. You would think I could remember the alphabet. Noah.
If we we get a question like this on the test, how are we supposed to answer it without going off?
I'm sorry, without what?
How are we supposed to do it like without going off like the paper?
So every year when I hand out the first test, kids go, oh my gosh, it's so big, because I will literally give you a full piece of paper for the FRQ. So it'll feel thicker than it actually is. Anna?
For the spread, do you not have to mention the numbers if you just still IQ-wise for the numbers?
You can if you want to. It'd probably be better, but since I was running out of space, I was being lazy.
Okay, so you should. Okay.
Any other questions? Hannah?
Was that the FRQ?
That was part A of the FRQ. That was part A. Now we're going to look at part B and part C. And that's it for that one. I don't think I've ever seen a, maybe a part D, but I don't think I've ever seen like a E or F. Unless it's something really simple like part A's find the mean, part B's find the standard deviation. All right. Any other questions before we move to B? Eric? Fine. All right, so part B, by the way, I just copied the box plot down here for you again. So part B says the 20 concentrations of aldrin for river X are given below, and then they're given. We're going to construct a stem plot that displays the concentrations of aldrin for river X. So part B, in my opinion, is not too bad. Just make a stem plot, right? So let's put T. What's the smallest concentration? 3.4. So the min is 3.4. What's the max? The 8.7? This one right here, 8.7. So I think that making the stems the ones place and then the leaves the decimals is a good way to make our stem plot here. So I need to go 3 to 8. So 3, 4, 5, 6, 7, 8. Biggest thing to remember is that your leaves need to be in order from smallest to biggest. So we have 3.4 and 3.7. Those are the only 3's, correct? Okay. So 4, 7, and then 4.0. I have a 6, but I have a 2 first. So there's a 4, 4, 4, 4, 4, 4. So 2, 3, 6, 6, 7, 8. And then for my 5s, I have 5.1. And then I have 3, 3, 5, 6. So 1, 3, 3, 5, 6. No 6s. Then we have a 3 and a 5 for 7. And then we have 0, 2, 6, 7. 0, 2, 6, 7. What else do you need to do with a stem plot?
Make a key.
You have to make a key, thank you. So I always pick a number on my stem plot, but we don't have to. So I'm going to go with 4-0. Tells me that's 4.0 parts per million of alderon. Right? Aldrin. So that's part B. Like I said, to me that one's not bad. Like a stem plot, it's not bad. Okay. Somehow I volunteered myself to teach statistics, and quite honestly I think it's one of the most applicable maths, and that we should focus on it more. And actually the Oregon Department of Education is starting to push that, which I think is great. Not everybody needs to know pre-calculus or calculus. But somehow I volunteered myself to do all this writing, and I am not a word person. So this part of me is not fun. That was fun. All right. Any questions before we look at C? Yes.
Do we have to like split it? We only split one thing. It's like large, right? There's a lot of data.
Yeah, so, I mean, if you really wanted to, you could split the stems on this. I don't think well, yeah, you're splitting stems. I don't think that having a list of 7 is a huge amount. I mean, if I did it really quickly, just so we can compare the two, 3, 3, 4, that's not going to fit there.
You get a little.
3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. We'd have 4 there, 7 there. Yeah. 0, 2, 3, 6, 6, 7, 8. 1, 3, 3, 5, 6, 3, 5, 0, 2, 6, 7. So, if you split stems, which means that like on the first stem I put any leaves 0 to 4, and on the next stem 5 to 9 leaves. So if you turn them sideways, I mean, you can see we already knew that it was skewed to the right from the box plot. You can kind of see that it's skewed to the right if you split the stems. It's kind of, I mean, it's not any more obvious. The biggest part, which we're going to get to in part C, is that you have this empty space here that you don't see in the box plot. If it specifies split stems, split the stems. But if it doesn't, then it's really up to you. I would think that if you're getting into like 10 to 15 leaves on a stem, it might be beneficial. But under 10, it's not. I mean, you can kind of see. I mean, you still see there's one high peak that still happens here. Even though we know it's skewed to the right, like if I tried to draw like the shape, I cut through that, all those numbers, and I cut through them down here. So in this one, I don't see a huge benefit to splitting the stems. If there were 10 to 15, I might. So, yeah.
So like when we first learned this, we did like a split. It wasn't like a split stem, but you have numbers on the right and numbers on the left. of the middle of the stem.
Mhm.
What's that called?
That's called a back-to-back stem plot.
Back-to-back stem.
So they would
I
give
thought
you two different
two
sets
different
of
sets of
data.
data or data.
Yes.
I thought like split stem plot was that. I was really confused.
Yeah, I could see where you would think that would be split stems. So if you have stems with data on each side, it's back to back.
Okay.
If you list the stem twice, that's splitting the stem.
Okay. Thank you.
Uh-huh. Any other questions before I go over C? And I kind of already gave away the answer to C. So C says, describe a characteristic of the distribution of aldering concentrations in river X that can be seen in the stem plot but not in the box plot. And we can see that we're missing all this data in the 6 range. There's like nothing here. There's this big gaping hole, but if we look from 5.6 to 7.3, 5.6 is like there-ish, 7.3 is around there. It looks like we have a bunch of data in there based on the box plot, right? But if we put it into a stem plot, we can see that there's this big gap of no data from 5.6 to 7.3. So that would be what we can see from the stem plot, but not from the box plot. Questions about that one or anything in general? Michelle. I'm sorry, I did not hear.
When you were doing the box plots, how did you zoom in? Like it only has one sheet or stuff like that.
So with a box plot, you can't determine unimodal or bimodal.
And my question C would be in that you can see that.
Oh, that'd be a great thing to add. You're right.
Yeah.
So the stem plot also shows that river X's distribution is unimodal. And I abbreviated distribution. Am I off the board? Okay, thank you. I need to learn to write smaller. Any other thoughts, questions?